I'm not going to be here after recess. I've got an appointment to get to. You'll have a relief teacher. So we won't set too much. We're going to go through 7E.1 and 7E.2. Initially we had the idea of going through E3, but I think it might be a bit complex for now, especially if I'm not going to be here to help out. So we'll just set these two, and then we can dedicate some time to the folio. And just on the folio, thank you for all of those that submitted your draft. So they were of varying quality, which is what I expected, but I think the most important thing is that you sort of submit something. Now, to those that have, they've received their draft feedback. So what that consists of is the first thing is a video. So that's me. What I've done is I've opened up your work and I'm scrolling through it and giving feedback directly to your work. Okay, so make sure you access that because I spend a fair bit of time doing those. And your feedback, I say, is proportional to how much you've done and how much you need to do. So they are of varying lengths as well. So make sure you watch that. That's going to be the most important thing. That's personal feedback directed towards your report so far. Then I've attached two general documents to the email. Both of these are very useful. First is just a generic report format. It's how to write a report, how to lay it out. The second is a checklist, which basically includes a list of all of the things you're going to need to include for your assignment to go through and tick off as you've met those criteria. Are there any questions about feedback I've given in general at this stage? Okay, very welcome to ask me about feedback I've catered to you. Definitely it's a good way for us to convey the feedback. Let's get straight into solving graphically. So this is going to be exercise 7E.1. And what we have here is we have a graph of the cosine function. And we have cos x equals 0.8. And we have to solve for x over this interval between 3 and 13. So 3, that's occurring, I don't really have an axis here, it's occurring about here. There's 3 and 13 is here. So that means we're going to solve the equation over this interval between 3 and 13. And we're asked, what is the value of x when cos of x, when the function equals 0.8? Okay, so 0.8, so here's 0, here's 1, 0.8 is going to be about here. Okay, you can get that from your graph on the paper. And if we draw a straight line across there, what we're looking for, the solutions are going to be when 0.8 exists on the cosine curve. So we can see we have 3 solutions. All right, so here the function has a y value of 0.8. Here the function has a y value of 0.8. Here it has a y value of 0.8. And we're restricting it to that region. We're not interested in to the right or to the left of that region. We're talking about between 3 and 13. So that's how we're generating those values. And we're interested in the x values that make it true. So we've got to get those as best as we can. So looking at your graph, between 3 and 13, looks like the first one is about 5.5. Okay, and the second one is about 6.9. All right. So our first solution, we're going to have x is 5.5-ish. We have 6.9-ish. Now, one way that you can communicate an answer is approximate is rather than saying equals, we can use squiggly equals. Whoops. And what that means is it's a roundabout equal to. Okay, so based on our estimate here, 5.5, 6.9, maybe you've got better eyes than me, and probably 12. All right, so those are the values where the cosine value is equal to 0.8. All right, is everyone okay with how I've generated that? So we're looking at the graph, we've restricted the region. We want to know what's the x value when the y value is 0.8. Y value is 0.8 here, here, and here. Okay, let's move on to the next one. The next one says find cos of 4. So this time they're giving us an x value. They're saying the x value is 4. What's the corresponding y value? So we'll find 4 on our axis. It's about here. There's x is 4, and the corresponding y value on the function is going to be here. What's the y value of that point at 4? and it's about negative 0.7. So cos of 4 is about negative 0.7. Now with this, we are estimating, so your answers won't be exact. You'll be using a ruler and just using your ruler along those graphs there, which will help it be a bit more precise for you when you're answering. Okay, so that's what we're going to be doing in 7E.1, right? We're looking at graphs and we're approximating answers for x values and for y values. All right, very good. So then in 7E.2, we're going to be using technology. And there's two ways we could use technology. The first would be to graph it, restrict the V window, and then G-solve solutions. That's perfectly suitable, but there is a faster way, all right, which is the second procedure, which we're going to go through. We're going to pull our calculators out. Whenever we're using technology, we need our calculators. And if we can go to our main run map menu, and here's our calculator instructions. We're going to go Option, Calc, Solve N. All right. So here's the syntax that we type in whenever we're doing solve n. We're going to have solve n, and it opens a bracket for us. And what we are going to type in is we're going to type in the equation that we're solving. We're solving it for x, so we type in the letter x. We type in the lower boundary and then the upper boundary of the constraint. And then we close the bracket and we evaluate it. So in our first circumstance, we're solving this equation, sin x equals 0.542. Our syntax is going to be solve n, the equation. All right, so we type in the whole equation, including the equals. All right, sin x equals 0.542. So, and we'll need to be set in radians as well, by the way. If you're not in radians, you can check at the top, remember. So sin x equals 0.542, comma, x. Okay, we always put an x there because we're solving the equation for x, comma, our lower boundary. Now we are asked in the question, it will always give you some constraints. We are asked to solve between 0 and 3 pi. It says solve all of these. All of these are going to have the same boundary from 0 to 3 pi. So our lower boundary is 0, our upper boundary is 3 pi. We're going to close the bracket and press evaluate. Now it'll say more solutions may exist. That's always going to be the case, and we just ignore that. We press exit because we've set the boundary according to how it should be, and these are our solutions here. We have 0.573, okay, so it's 5728, and I've rounded the 8. We have 2.568, which will be 2.57. And we have 6.856, which will be 6.86. And we scroll across, we've got one more, 8.851, which will be 8.85. Okay, so all of the solutions are separated with a comma. It's given us lots of decimal places there. All of those solutions are stated there. Okay, so what we would do with B then, we're going to do the same process. We'll type in solve n. We'll type in our equation, which is 3 cos 2x plus 1 equals 0. That's the whole equation. We type in what we're solving for. We're solving for x. Our lower boundary is 0, upper boundary is 3 pi. So you can just go back up to the previous thing you typed in and just change the equation. Okay, more solutions exist, and we'll have our solutions are 0.955, 2.19. 4.10, and 5.33. Now what I might even do with our last one is talk about the rounding. Alright, just so we're all clear, 5.33, yep. There's more, 7.24 and 8.47. 6 solutions. Okay, then we'll do the last one. So we're going to type in our equation. So we have solve n. Our equation is cos x equals 2 sine 2x. We're solving for x from 0 to 3 pi. Okay, so here I'm going to write out our solutions to 4 figures and then round to 3. 2 sine 2x. Okay, so we have 0.2526, we have pi on 2, we have 2.888, and we have 3 pi on 2, and we have 6.535, we have 5 pi on 2, and then we have 9.172. Okay, so for all of them, I'm going to talk to these about how we're rounding our answers. So for all of them, I've written 4 figures, except these ones. These are what we call exact form, so we'll leave those as they are. Sometimes our calculator will give it to us in exact form. Sometimes if it has an irrational answer, it can't process it in exact form, so we just write it to 3 significant figures. So what we do, we write 4 figures, the first 4 non-zero figures, and then we round the 6. 6 rounds up, which means this one is 0.253. Okay, here we've got 4 figures. The 8 at the end is going to round up, so we will have 2.89 to 3 figures. 6.535, 5 rounds up, so that's going to be 6.54. Okay, now here, notice the difference between, here we've got 4 decimal places, but here we've only got 3, but they're both still 4 figures. There's 4 figures written here, and there's 4 figures written here. We're always going to write 4 figures and round the last one. Okay, so we're writing 4 numbers, rounding the last one. 9.172, there's 4 numbers there, and we're going to round the last one 2 rounds down. So this is our 9.17. So that's how we're performing the rounding there, just explicating that in the last one. So this is enough for us to work through exercise 7E.1 and 7E.2. That's going to be our plan for today. So after recess, we can continue with this, or you can start to have a look at some of your draft feedback and work on your folio task.